All right, what we're going to do here is show that this function, f of x equals x minus cosine x, has at least one zero. So what we're going to do is to show there's some number c such that f of c equals 0. Now, first of all, here's my solution. I am going to start off with a statement that I'll put a bullet. It's not usually used in math. It's sort of like I don't know, like Microsoft Word or something, bullets and so forth. But f is continuous. So using bullets is not something you usually see in math. F is continuous. Well, we'll pick an interval later, but let's say because it is a combination of a polynomial and a trig function. Now, my basic tool is I'm going to try to brainstorm and think of a number where the function's positive and another number where the function is negative. So I'm going to find where it's positive and then where it's negative, and then the zero has to lie in between there. So I'm going to start off with what I consider sort of the easier one, which is plugging a zero. And it's not like I really have a plan in mind, but I thought, well, why wouldn't I put in 0? Why would I start off with, something more difficult? I could do like 5, 6 pi, but like, why do that one if I haven't even done 0 yet? So we'll plug in 0. Here I'm drawing the unit circle on the side over here. But if I put in 0, I get 0 minus cosine 0. And cosine 0 is 1. So if you remember on the unit circle, cosine is the x coordinate and sine is the y coordinate. Oops. So that's why I drew that. So we can refer to that. Okay, next, let's try to pick another easy number. And to me, it's not, quite so obvious what I should do. I think I could do pi. That's I think they call it a coaxial angle. Maybe, or no. Anyway, I'm just going to do an angle on the y-axis. I'll do pi over 2. And but I in another class I did pi. But let's see what happens when you put pi over 2 in. Maybe it won't work. Maybe I'll erase it. But let's just go ahead and put pi over 2. I think it will work though, because pi over 2, or cosine again, is the x coordinate, and so at pi over 2, the x coordinate is 0, and so this is going to give pi over 2 minus 0, which is equal to pi over 2. So what do I see is that f of 0 is negative and f of pi over 2 is positive. So we see that f of 0 is less than 0 and f of pi over 2 is greater than 0. It doesn't even really interest me for this problem what those values are. It's just the one's negative and one's positive. And by the way, I'm going to go back and pretend that I had this planned all along. F is continuous on the interval from 0 to pi over 2. So that's going to be my interval. Now, where is this all leading up to? This is an application of the intermediate value theorem. All right. So I have f of 0 is less than 0. That's too little. We want to find a number where the function is equal to 0, or we want to show that it exists. F of 0 is too little. It's less than 0. F of pi over 2 is too much. It's greater than 0. But because the function is continuous between 0 and pi over 2 on the interval from pi over 2, because it's continuous, therefore, there exists a number c. C is going to be between these x values. So c is an x value, and it's between 0 and pi over 2, such that f of c is equal to 0 by the intermediate value theorem, which you could just call IVT. And that, I think that does it. What else is there? Sketch a graph, sort of. Well, anyway, I'll just leave it like that. Trying to draw a little rectangle. Okay, anything else about that before we move on to something else? All right, let's shut down the video. Goodbye.